Okay. So just to review, this is the graph of y equals x. Okay. What if I asked you to graph, and don't write this down because this is actually not, you can write it down if you want. What would you do if I asked you to graph that? What? Y values, you guys, not the x values. So in the original, like we would have 0, 0, 1, 1. We could pick just 3 points. Maybe we should get points down here. -1, 1. -1, -1, pardon me. And then the absolute value we take of the y coordinate, not of the x. Okay? Only the y. So this is 0, 0. This is 1, 1. This is -1, 1. Which means that it's going to be this section, should have done a different color, and then this for absolute value. Right? Because remember, absolute value, whatever's below the x-axis gets flipped above. So this section here gets flipped up. This is already above, so it stays with the graph. My point is, we took the absolute value of x, right? Or y. Ooh. We took the absolute value of y. We're going to do the same thing, except this time we're not going to take the absolute value, we're going to take the square root. So how do you think you would take the square root of a certain function? Take the square root of all the y's. Just like with absolute value, we take the absolute value of all the y's. So on this graph, give me a point, or let's start with this. -1, and I kind of, that's what it looks like. -1, -1. Pardon. This means take the absolute value of all the y's. So this point would be -1, the x doesn't change. What's the square root of -1?
You can't do it.
Can't do it. Can't take the square root of a negative, right? So therefore, there's no point there. No point exists. Let's try 0, 0. If I took the absolute value of the y coordinates, I'd still have 0, 0, wouldn't I? So this is a point on the square root function, but I still don't know the square root function yet. Give me another point on this red one where I can easily take the square root of the y coordinate. Okay, give me 2. I heard 4, 4. Can't do negatives. Can't get the square root of 2 easily.
1.
1. So let's go 1, 1. What would the square root of the y value be? What would that point turn into? 1, 1 again. It doesn't change. So this would also be a point on the square root. And then you guys said, okay, how about this one, we'll take 4, 4. What does the point become on the square root one? 4, 2. Because remember, we're taking the square root. And doesn't that make sense with how we graph these things?
Yes.
So, and what would the invariant for? What are the invariant points for this one? 0, 0, 1, 1. Okay. Let's look at another line that we're going to square root. This time we're going the other way. So this is the equation of the line. I don't really care about what this is. I want to take the square root of it. So what were the points that I tried in the last one? Well, last one, I tried 1, -1, -1, but that doesn't exist on this one. 0, -1. Let's try 0, -1. What would the point be on the square root? 0, can't do, I'm fine. So that means there's no point here on the square root one. Which makes sense because you can't take the square root of a negative number. What's the next point along here that you would want to take that you can easily take the square root of the y value? We tried this one. How about -2, 0? Because what would be the point on the square root one when we square root the y? -2, 0. Give me the next one moving up and we could easily take the square root of -4, 1, right? Notice you guys are going to the ones where y is 0 and y is 1. Because -4 square root of this is still 1. So we had -4, 1. There is 4 up there. -10, 4 becomes what when we square root the y's? -10, 2. -10, 2. So it looks like this. Which makes sense, because that's the way these square root ones are looking. What are the invariant points here?
-2, 0, -4, 1.
Look at the invariant points on the previous page and this page. What's common?
First 2 points.
The first 2 points?
The first one we graph. Or on the.
I'm sort of asking you to look at these. Look at the actual numbers. Look at the numbers of the invariant points. The y is 0 and then the y is 1, right? Because if you take the square root of 0, you get the exact same answer. If you take the square root of 1, you get the exact same answer. So therefore, whatever points on the original where y is 0 and y is 1 will be on the square root. It'll be the exact same points. So like if I said this, Here's how we can graph without having to do this work. What if I said this? Where is there a point on the square root? Where y is 0, right? What point on this graph is y 0? So this is on the square root 1. What other point? Where y is? Where y is 1, which is here. What does the shape look like? It's a sideways parabola, half a parabola. Boom, we're done. That's it. That's all you have to do to graph them. Find the points on the original where y is 0 and y is 1, and then draw your sideways curve. And you're done. So you don't have to worry about doing a table of values. So I'm actually going to skip ahead to this one. We can do this without having to do a table of values, without having to, without having to do a table of values. What will the same points be on the square root 1? Where y is, okay, where are the points on this graph where y is 0? Here and here. Those are going to be on the square root graphs. Where y is 0, where y is 0. The other points that are going to be on the square root graph, where y is 1. Here and here. And it's a sideways curve, isn't it? So there's two sideways curves in this one. It goes like this, and it goes like this. That's the square root function. So on a parabola, a right side up one, there's going to be two of them going opposite directions. If the original function's a line, like we did in the first two examples, there's only going to be one curve. How about this one, upside down parabola? Points on the square root would be where y is 0 and where y is 1. Where are the points here where y is 1, here, and here? Right? Notice this time the curves are going towards each other. Because this is where it starts. This is to the left, so it's got to move to the left. This is where it starts. This is to the right, so it's got to move to the right. Question is, where do they meet? Do they meet here, 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 here? Where would they meet? What's this point? 0, 4? What's the square root of 4? So it would meet here. So it would look like a semicircle. That's crazy. And let's look at this final one. How do we find the square root function? Find the point or points where y is 0. In this case, there's only one. Find the points on the original where y is 1. How many of them are there? There's two of them. There's one here and one here. How many curves do you think you're going to have? Here's the starting point. Your starting point is always on the x-axis. Don't I curve one out there and curve one out there? So I got to go yoink And I got a little yoink.
We have to have an understanding, like.
You will be given the original graph
Okay,
and asked to graph the square root one.
okay. How do you know how like high, like,
Well, I know that it starts here and it's got to go here and it's got to go here. So that's actually there's two curves.
yeah, but like with how much your curve is at.
Oh, sorry. How much the curve?
Like, cause you can easily like make it 5 lines.
Yeah, I understand what you're saying. Yeah. Yeah. Notice, I don't know if you've noticed, but I've been drawing between the y equals 0 and y equals 1. I've been drawing it over top the graph. Notice how I draw it on top of the original. Notice how I draw it on top of the original, on top, and then I go underneath. Here, I went on top of the original, then underneath it. Okay, there's a reason for that. And it goes back to here. Goes back to the first page. Like here, the square root, this is the point, x is 0, y is 0, so the square root of 1 will be 0, right? This is the point here. You see. What would this point be here? Would you agree that that's half and a half? This is the point on the original, 1/2, 1/2. What's the square root of 1/2 or 0.5? Use your calculator. What's the square root of 0.5? Notice the answer got bigger. Whenever you take the square root of a number, it gets smaller, right? Or it stays the same. So like the square root of 4 comes down to 2. The square root of 9 comes down to 3. The square root of 0 stays at 0. The square root of 1 stays at 1. Okay, but the square root of a decimal number between 0 and 1 actually gets bigger. That's why I go higher between these two. And then I go lower. Okay, so to summarize, I know I'm jumping around a little bit on this lesson. Here's the summary. If you're given an original function, whether it's a line, a parabola, absolute value that we did, okay? The square root function if y is less than 0 or negative, the square root function doesn't exist. Because we can't take the square root of a negative number. Right? So like in this one, all these y values were negative, right? They don't exist on the square root one because I can't take the square root of them. So it starts at 0. Anything below 0 doesn't exist. At 0, the square root of y will also be 0. At 1, the square root of 1 will also be 1. Those are the invariant points. These are the invariant points. And remember, between 0 and 1, it's greater, isn't it? And then it goes less. So between 0 and 1, the square root is greater than the original. That means it goes over top. And then once we move by 1, the square root gets smaller or is less than the original. Okay. I know there's one little section I missed, but I'll go backwards. Okay. Volunteer. Who wants to try it? To graph the square root one. Remember, find the points where y is 0 and y is 1, and then go over, under. That point, over, under. Perfect, with an arrow. That's okay, you're good. Well, now it doesn't come back down.
Have you read?
No, go ahead, go back, yeah. Yeah, not finished yet. Yep. Sure. But don't keep curling it down.
It goes straight.
No, it goes like this. Put the arrow here. There you go, perfect. Because it doesn't straighten out and it doesn't go back down. Perfect. Yes. Ideal. No, I know. Who wants to try? Yeah, that. Who wants to try this one? Huh?
Okay, this is y equals 1.
Yeah, that's y equals 1. Over under. Yep. And over under.
Oh.
You know, you want to go a little bit more. Just 50. There you go. Perfect. Yeah, well done. Thank you. Okay. Are we getting the idea?
Yes.
Okay, Elsie, question?
No.
Oh, sorry. Okay, let's finish this off. I mean, this is pretty straightforward. Going back to the second example, what's the domain of the original? What's the domain of the original line? What's the range of the original line? Good. Negative infinity to positive infinity. What about the domain and range after we square rooted it? Negative infinity to -2 equals negative infinity to negative 2, and the range is 0 to infinity. The range will always be of the square root function, will always be 0 to infinity. Because we always started on the x-axis, don't we? And then we go up. So this will always stay the same. This will change depending on where the x-intercept is. Wherever the x-intercept is, that will dictate what the domain is. So how does the range of f of x affect the range of y equals root x? Well, the range of y equals root f of x will always start at 0. And I shouldn't say it'll go up to infinity, because there was one example that we did where it didn't go up to infinity. It'll always start at 0. But remember this example? What's the range of this one?
Oh, 0 to 2.
0 to 2. It doesn't, because when they curve in at each other, it doesn't go up to infinity anymore. Only when they curve out does it go up to infinity. Okay.